everyone. Today we're going to be doing 2020 Aime I question 10. Let m and n be positive integers satisfying the conditions. GCD of m plus n and 210 is 1. M to the power of m is a multiple of n to the power of n, and m is not a multiple of n. Find the least possible value of m plus n. Based on the first condition, we know that 210 is equal to 2 times 3 times 5 times 7. This means that m plus n cannot have any of these multiples. I'll write it like this. They cannot divide into m plus n. Based on the second case, the second restriction, we have that m to the power of m is a multiple of n to the power of n, which means obviously m and n have to have a common factor. So this means that GCD of m and n is greater than 1, and it's not going to be divisible by 2, 3, 5, or 7 again. So 2, 3, 5, 7. Do not divide it. And finally, m is not a multiple of n. So how can that happen? If you have m to the power of m is a multiple of n to the power of n, but m is not a multiple of n, then the only way that can happen is if the power of the GCD in n is greater than that in m, which means, let's say m equals, first let's say that the GCD is equal to a. The GCD, let that be equal to a. Then we'll say that m is equal to some other number times that GCD, and n we'll say is equal to a because we want to minimize m plus n. So we're going to have n is equal to a to the power of something, and m is equal to x times a to the power of something. Now, since we want to minimize m plus n, we want our GCD to be the minimum possible value. And because we can't have any of these prime numbers, the next prime number that comes after that is 11. So I'm going to start by saying that a is 11. So then I'll say this is x times 11, m is x times 11 to the power of something, and then n is 11 to the power of something. And since we, again, want to minimize it, we'll make the exponents minimum too, so that the exponent of n is still greater than the exponent in m. So then we'll just say 1 and then 2. So that means that n is equal to 121. And we still need to find what x is. So let's go back to our second condition, where we're going to have that m to the power of m is a multiple of n to the power of n. N to the power of n is equal to 121 to the power of 121, which is 11 squared to the power of 121, which is 11 to the power of 242. Since we want m to the power of m to be a multiple of n to the power of n, we need to have that the power of 11 after you exponentiate it with m, that has to be greater than 242. So that means m to the power of m equals x times 11 to the power of x times 11. Actually, that looks better as 11 times x. 11x to the power of 11x. That's better. And then you can write this as 11 to the power of 11x times x to the power of 11x. So we want this 11x to be greater than 242. So then what minimum value of x does this give us? Well, we know 242 is 22 times 11. So then that means the next number higher than that is 23. So we're going to start by saying x equals 23. But we're not completely sure if this will work yet. So let's just plug it in and see what happens. We have m equals 23 times 11. And n equals 11 times 11. When you add these two together, you're going to get 23 times 11 plus 11 times 11, which factorizes to be 11 times 23 plus 11. But this turns out to be a multiple of 2 and 3. Wait, sorry. Oh, that's 34. It turns out to be a multiple of 2. So this does not work because we're not allowed to have that for m plus n. So then what can we do? Well, we know that we can test out any number greater than 23 because that will still keep the exponent greater than 242 and it will satisfy restrictions 2 and 3. We're just worried about restriction 1 right now. So we can just test out all x plus 11 starting from 24 and see, we find the first number that is not divisible by 2, 3, 5, or 7. So when x is 24, we get 35, which does not work. When x is 25, we get 36, which does not work. When x is 26, we get 37, which is actually a prime and is not divisible by any of those numbers we said before. So that means that works. So then we'll conclude that x equals 26, since we want to minimize it, and this is the minimum number we get. So yes, the 23 turned out to be wrong. So finally we have m equals 26 times 11, and n equals 11 times 11. M equals 286, and n equals 121. Finally, we just need to add these together, and this gives us 7, 0, and 4. So our answer is 407. Thank you for watching. Have a nice day.